Ever feel like you're wrestling with data, trying to get it to behave
Hmm.
and look just right in your software? That ability to clearly display and format information is kind of like having a secret weapon.
It really is.
You're here to gain knowledge efficiently, and today we're diving deep into exactly that.
That's right. In this session, we're going to explore the foundational techniques in C Sharp, the ones that allow you to take control of how your data is presented. We'll be focusing specifically on the essential tools for string manipulation and basic numerical operations.
Yeah, we've got some excellent introductory C-sharp material lined up. It covers, well, everything from those little formatting tricks using special characters and the different ways C-sharp handles text,
Right.
all the way to the fundamental operations of arithmetic, making sure we understand how different types of numbers behave.
And to really, solidify these concepts, we'll be looking at a couple of practical scenarios, building a simple student grading system and a GPA calculator. These examples will show you how these fundamental building blocks are used in, well, real-world coding situations.
So our mission today is pretty straightforward.
Yeah.
We're extracting the core principles and practical uses of these C-sharp essentials.
Hmm.
We want to give you those aha moments that make these concepts truly click and provide insights you can immediately use.
Exactly.
Okay, let's unpack this, starting with how we can make our text do exactly what we want.
Let's start by looking at escape sequences. These are special character combinations, always beginning with a backslash, that tell C Sharp to interpret the following character in a
Oh,
specific way.
okay.
Think of it as a way to represent characters that you can't easily type directly within a string.
Right, it's like a little secret handshake to get special formatting. For instance, if you need a new line in your text output, you don't just press enter in your code.
Hmm?
Instead, you use N.
Mm-hmm.
So if you write console.writeLine, hello world,
Mm-hmm.
the result will be hello on one line and world underneath it. And similarly, two inserts a tab space. So console write line, hello world will
Yeah,
give you that nice horizontal gap between hello and world.
exactly. Now, what happens if you need to include, say, a double quote character within a string that's already enclosed in double quotes?
Oh, yeah.
If you try something like console write line, hello world, the C Sharp compiler will just get confused. It'll think the second double quote is the end of the string.
And that's when your code editor lights up with error messages.
Yeah,
The compiler just can't make sense of it. It's expecting something else entirely.
totally.
The solution is the escape sequence. So console write line, hello world, tells the compiler, okay, treat this double quote literally as part of the text. And the output, hello world.
And another really common issue comes up when you're working with file paths on Windows, right? Because they use backslashes.
Oh, yeah, definitely.
If you try console.writeline C source repos, C Sharp will see the she as potentially the start of an escape sequence it doesn't recognize, maybe giving an error or warning.
And the R in there is actually a valid escape sequence for carriage return,
Right.
which is definitely not what you want in a file path.
Exactly. C Sharp reserves that backslash to signal the start of an escape sequence. So to actually display a backslash character itself, you need to escape it with another backslash.
Okay. Double backslash.
Yep. Therefore, console.writeline C source repos will give you the file path exactly as you intended, C source repos.
Makes sense.
And to see a practical use of these, imagine you're generating invoices. The code snippet console, WriteLine, generating invoices for customer Contosa Corp, uses N for a blank line.
Right.
And then lines like console WriteLine, invoice of 21 complete, use T, actually two tabs there to neatly align the invoice numbers with their complete status.
Okay, so you get that nice column effect.
Yeah, and then maybe console WriteLine output directory
Hmm.
uses another new line and a tab for the label. It helps structure that command line output.
Okay, so escape sequences are the way to go for inserting those specific kind of hard-to-type characters or formatting bits. But what if you have a bigger block of text, like maybe a file path or some code snippet, where you want C# to just ignore any special meaning of backslashes or white space?
Ah, right. That's where verbatim string literals come into play. You create them by placing the @ symbol right before the opening double quote of your string.
The @ symbol. Okay.
When you use this, all the white space within the string spaces, tabs, new lines is preserved exactly as you type it in your code. And crucially, Backslashes are just treated as literal backslashes.
Ah, so no escaping needed for paths.
Exactly. So instead of ending up with that, slightly messy C-source repos, you can simply write console writeline at C-source repos. This is where your code goes.
And it just prints exactly that, with all the spaces and the single backslashes.
Precisely. All the leading spaces, the spaces in between, the single backslashes, just as you typed them.
That sounds much simpler for paths.
It often is. And building on our invoice example, if you then have the line console right at C, invoices, immediately after the output directory T line, because you use console, right, not write line.
Right, no new line.
The verbatim literal means it will just append C invoices directly onto the same line in the output, exactly as written.
Okay, got it. Now let's talk about characters from, different languages. How do we get those into our strings? I know there's Unicode for that.
Yes, Unicode. It's the global standard for encoding characters from pretty much every writing system. In C#, you can include these Unicode characters using the escape sequence followed by a 4-digit hexadecimal code.
4 hex digits.
Right. This code represents the specific Unicode character, and C# primarily uses the UTF-16 encoding for this.
So, for example, if you want to say Konnichiwa world with Japanese characters, you could write console write line 23053 U306B03 U30613 U306F world. That whole U part represents the Japanese characters.
Exactly. What's amazing here is just the sheer breadth of characters you can represent. But it's important to be aware that not all systems display these characters perfectly.
Oh, right, like the console window sometimes.
Yeah, exactly. For example, the standard Windows command prompt might just show some Unicode characters as question marks or boxes. It depends on the font support and the console itself.
Okay.
Also, while U uses UTF-16, some less common characters, like maybe certain emojis or historical scripts, actually need UTF-32 encoding, which uses a different syntax, U followed by 8 hex digits. So dealing with Unicode properly, especially for global applications, can get pretty intricate. It's definitely an area for deeper study if needed.
That makes sense. The example code shows this with the Japanese phrase shuchasi, which uses those U codes, followed by a command line example using a verbatim literal console.writeline at C invoices app.exe baj. So you're combining techniques there.
Right. You might use Unicode for, say, a localized instruction and then a verbatim literal for the command itself, which might contain file paths.
Okay, so let's quickly recap string formatting so far. We've got escape sequences like N for special characters.
Don't forget for a literal backslash.
Right, for the backslash itself. Then the @ symbol gives you verbatim literals, keeps everything as is.
Yep, preserves layout, treats backslashes normally.
And U plus a hex code lets you use Unicode characters, though display might vary.
Correct. Now let's move on to how we can combine strings together.
Sticking strings together. The most basic way is using the plus operator, right? String concatenation.
Precisely. When you use the plus operator with strings, it doesn't do math. It just takes the string on the right and appends it or sticks it onto the end of the string on the left.
Gotcha. So if you have string first name Bob, and then you write string message hello plus first name console, white line message, the output is simply hello Bob.
Exactly. You're just joining the value of the first name variable to the end of the literal string hello.
And you can chain these together too, right? Like
Yeah.
string greeting hello, then string message reading plus first name plus first console.writeline message gives you hello Bob.
Yep, works perfectly.
Yeah.
For combining multiple variables and literals. One thing to maybe keep in the back of your mind, though, especially if you're doing lots of concatenations in a loop, is performance. Each plus can potentially create a new temporary string object in memory.
Oh, okay. So for really heavy-duty string building, there might be better ways, but for simple cases, it's fine.
Exactly. And the material also makes a good point about avoiding unnecessary temporary variables sometimes. Instead of declaring that separate message variable, you could just do the concatenation right inside the console, write line, call, like console write line greeting plus first name plus date.
Right. Makes the code maybe a bit shorter.
While concatenation definitely gets the job done, a more modern and often much more readable way to combine strings in C# is string interpolation.
Ah, yes, the $sign of the curly braces. I like interpolation.
Me too. You put a $sign double quote of your string, then inside that string you can put any valid C# expression inside curly braces.
And its value just gets popped right into the string.
Exactly. Its value is calculated and inserted right there. So instead of our previous example, string message greeting plus Oprah plus first name plus Oprah, you can write the, I think, much cleaner string message Oprah first
Oh
name.
yeah, that looks way more readable. You can see the final structure much more easily.
Totally. And we see this in other examples, like string message hello first name, again, hello Bob, or combining different types, like in version 11, string update text, update to Windows, console write line gives update to Windows 11.
And you can even put calculations or method calls inside those braces, right?
Absolutely. Anything
Yeah.
that evaluates to a value you can put in there. And what's really neat is that you can combine verbatim literals with interpolation too.
Oh, how does that work?
You just put both symbols before the string. So if you need a file path that includes a variable, you could write string project name, first project, console, write line at C output project name data.
Ah, so the @ handles the backslashes literally,
Yeah.
and the deal handles the project name variable.
Exactly. You get the best of both worlds.
That's really handy. Okay, so interpolation seems like the preferred way for building strings most of the time now. Powerful and readable.
Generally, yes.
So quick recap again.
Yeah.
Escape sequences, verbatim literals, Unicode, beta concatenation plus, and the very convenient interpolation. That covers a lot for strings.
It does. Ready to switch gears and crunch some numbers?
Let's do it. Basic math in C#.
Absolutely. So in C#, you can perform all the fundamental mathematical operations, addition, subtraction, multiplication, and division using the familiar operators. Plus, at Herbach and VShark. Pretty straightforward.
And we already saw that plus is overloaded, right?
Yeah.
It does concatenation for strings, but addition for numbers.
Correct. So if you have int first number 12, int second number equals 7, console write line, first number plus second number. C# knows these are integers, so it performs addition and outputs 19.
Okay. But what happens when you mix strings and numbers with that plus operator?
That's where it gets interesting, and you need to be careful. Take string first name, Bob, int widgets sold equals 7, console write line first name plus sold plus widgets sold plus widgets. What C# does here is it sees the string sold, then it sees the integer widget sold. To combine them with plus up, it implicitly converts the integer 7 into the string 7.
Ah, so it becomes string concatenation again.
Exactly. The whole line becomes string concatenation, resulting in Bob sold 7 widgets.
But what about this example? Console, write line, first name plus widgets sold plus 7 plus widgets. I remember the output was weird.
Right. The output is Bob sold 77 widgets because the compiler processes it generally from left to right. It does first name plus os sold, string, then plus widget sold. Since one side is a string, it converts widget sold 7 to 7 and concatenates Bob sold 7. Then it sees plus 7. Again, one side is a string, Bob sold 7. So it converts the integer 7 to the string 7 and concatenates again.
Wow. Okay, so it never actually does the math 7 plus 7.
Not in that sequence, no. To force the mathematical addition to happen first, you need parentheses, just like in regular math. Console, write line, first name, plus sold, plus 7 widgets?
And that calculates widgets sold plus 7, which is 14 first, and then converts the result 14 to the string 14 for concatenation.
Precisely. Giving you the correct Bob sold 14 widgets. The takeaway, really, as the material suggests, is it's often much clearer to do your calculations separately and then format the string rather than mixing them in one complex line.
Good advice. Okay, so parentheses are key. What about the other basic operations? Subtraction, multiplication, division.
For integers, subtraction, multiplication, and division work pretty much as you'd expect mathematically. So in sum, 7 plus 5 is 12, in difference equals 7, 5 is 2, in product equals 7, 5 is 35. The one to watch out for is integer division. In quotient equals 7, 5 results in 1.
Just 1, not 1.4.
Nope. Because quotient is an int, and both 7 and 5 are treated as integers here, C# performs integer division, which simply discards or truncates any fractional part. The 0.4 just vanishes.
Ooh, that could definitely cause bugs if you're not expecting it.
Oh yeah, it's a classic trap. If you need that decimal precision, you have to use a different data type, like decimal.
Okay, so how do we use decimal?
Well, if you want to perform division and get a decimal result, at least one of the numbers involved needs to be a decimal type. You can signal a number is a decimal literal by adding an m suffix. So decimal quotient equals 7.005.
Not the m.
Yep, the m tells C# this is a decimal. Since one operand, 7.0 is decimal, the division results in a decimal, and decimal quotient will correctly be 1.4.
What if you have integer variables already, like int first equals 7, int second equals 5? Can you still get a decimal result?
Yes, you can explicitly convert or cast one or both of them to decimal before the division, like this. Decimal quotient decimal first, it's decimal second. That decimal tells C# to treat first as a decimal for this operation.
Got it. So casting decimal or using the M suffix are the keys for decimal division.
Correct.
Now, what about remainders? Sometimes you need the remainder after division.
That's the modulo operator %. It gives you the remainder of an integer division. So console right line modulus of 200% or 200% would output 0 because 200 divides evenly by 5, no remainder.
Okay.
But console right line modulus of 7 to 5 outputs 2 because 7 divided by 5 is 1 with a remainder of 2.
Right. Useful for things like checking if a number is even or odd.
Exactly. And we should also quickly mention the order of operations again, PEMDAS or BODMAS, whichever you learned.
Parentheses, brackets first, then exponents orders, then multiplication and division left to right, then addition and subtraction left to right.
Yep, C# follows that standard order. While there isn't a built-in operator for exponents, like in some languages you'd usually use systemmaps.pow for that, maybe something we cover later, the order for plamma plus I is standard.
And the examples show this clearly. In value 1 equals 3 plus 4, 5, does the 4, 5 first 20, then adds 3, giving 23.
Whereas in value 2 equals 3 plus 4, 5, does the addition in parentheses first 7, then multiplies by 5, giving 35. Order matters.
Definitely. Okay, lastly for basic math, let's touch on those shortcuts for increasing and decreasing variable values.
Yes, the increment, plus, plus, and decrement operators, and also the compound assignment operators like plus start. They're just shorthand.
So instead of writing value plus 1, you can write value plus 1 or even just value plus plus. They all do the same thing. Add 1 to value.
Correct. And similarly, value 1, value mass 1, and value 1 all subtract 1.
Makes code a bit shorter.
It does. But with plus, plus, and diet, there's a really important nuance, the difference between prefix and postfix.
Prefix means before the variable, like plus plus value.
Yeah.
And postfix is after value plus plus value.
Exactly. And they behave differently depending on when the increment or decrement happens relative to when the variable's value is used in the larger expression.
Okay, how so?
Prefix, plus plus value or value, increments or decrements the variable first, and then the new value is used in the expression.
Okay.
Postfix, value plus plus or value, uses the current value of the variable in the expression first, and then increments or decrements the variable afterward.
Ah, okay. The timing is different. That seems like something that could easily trip you up.
It really can. Let's look at the example. In value 1, then value plus plus, then console.writeLine first, plus value. Since value plus plus happens on its own line, it increments value to 2, so the output is first 2.
Right.
Now, console.writeLine second, this is postfix. It uses the current value of value, which is 2, for the output, so it prints second 2.
Right.
After that line executes, value is incremented to 3.
Okay, so it prints 2, but then value becomes 3.
Exactly.
Yeah.
Which is confirmed by the next line, console.writeLine third plus value. This prints third. Finally, console.writeLine fourth plus value. This is prefix. It first increments value from 3 to 4, then it uses that new value 4 for the output, so it prints fourth.
Wow. Okay.
Yeah.
You really have to pay attention to whether it's plus plus value or value plus plus if you're using it inside another statement like console write line.
Absolutely. It's often clearer to do the increment or decrement on its own line if possible to avoid confusion.
Good tip. And just to tie this back to a practical calculation, the material mentions that Fahrenheit to Celsius challenge.
Right. Using the formula Celsius Fahrenheit 32, 5, 9, the example code shows decimal Celsius Fahrenheit 32 meters, 5 meter, 9 meter.
Ah, using the M suffix again for decimals.
Crucially, yes. Using 32 meters, 5 meters, and 9 meters, and shows that the subtraction, and especially the division 5 and 9 meters, are done using decimal arithmetic, giving you an accurate fractional Celsius value, not truncated integer math.
And then it just prints it out using standard concatenation. Console write line, the temperature is plus Celsius. Even if the result has lots of decimal places initially.
Exactly. It shows the core arithmetic operations in a real-world formula.
Okay, this leads us perfectly into those guided projects.
Yeah.
Let's see how these string formatting and arithmetic concepts come together in slightly larger examples.
Sounds good. Let's start with the student grading application. The basic idea here is to calculate and display the final grades for 4 students, Sophia, Nicholas, Zahira, and Jian, based on their scores from 5 assignments.
Right, and the desired output is pretty specific. A list showing each student's name, their calculated average score, and then a letter grade, nicely formatted.
Yep. The provided code starts by setting up integer variables to hold each assignment score for each student. So Sophia 1, Sophia 2, etc.
Okay, storing the raw data.
Then it shows calculating the sum for each student, like int Sophia sum Sophia 1 plus Sophia 2 plus Sophia 3 plus Sophia 4 plus Sophia 5, simple addition. But then, to get the average score, it needs to divide that sum by the number of assignments. And here's the key part again. It casts the sum to decimal before dividing. Decimal Sophia's current assignments.
To avoid that integer truncation we talked about.
Exactly. To get the potentially fractional average like 94.6, not just 94.
Makes sense. And then how does it display it?
It uses basic console write lines statements, but incorporates tab characters to try and line things up. For example, console write line Sophia plus Sophia score plus TA. The tabs help create those columns for name, score, and grade.
So just using tabs for basic alignment in the console output.
Right. It shows how fundamental arithmetic, that crucial typecasting to decimal, and simple string formatting with tabs work together to produce the required result.
Okay, cool. What about the second project, the GPA calculator?
This one's a bit more involved. The goal is to calculate a student's grade point average, the GPA, based on the letter grades they got in different courses and how many credit hours each course was worth.
Right. GPA involves weighting the grades by credit hours.
Exactly. The input data includes the student's name, course names, the numerical grade equivalent, like A4, B3, and the credit hours for each course.
And the output needs to be a nicely formatted summary, student name, then a table with course, grade, credit hours, and finally the calculated GPA, formatted to 2 decimal places.
Correct. The code starts by initializing variables for all this input data, course names, credits, numerical grades. Then it calculates 2 main things. First, the total credit hours, just summing them up, total credit hours plus course 1 credit, and so on.
Okay, just adding up the credits.
Second, it calculates the total grade points. This involves multiplying the credit hours for each course by the numerical grade for that course and summing those products. Total grade points plus course credit, course grade.
Right, so a 4-credit A gives more points than a 3-credit A.
Precisely. Then the GPA calculation itself is dividing the total grade points by the total credit hours. And again, crucially, it casts to decimal grade point average, decimal total grade points total credit hours.
To get the accurate GPA, which is usually fractional.
Exactly. Now, this example goes a bit further in formatting. It actually shows a technique using integer casting and the modulo operator to specifically extract and format the GPA to exactly 2 decimal places for the final display.
Ah, okay, so more advanced formatting than just printing the raw decimal.
Yeah, it demonstrates a way to get that precise 3.35 kind of output. And again, it uses console write line with tab characters to structure the output table for courses, grades, and credits.
So this GPA example really highlights breaking down the problem, get the data, do the weighted calculations correctly using decimals, and then apply specific formatting rules to present the final result clearly.
Absolutely. It pulls together the arithmetic, the type considerations, and the string formatting techniques quite nicely.
So thinking about this whole deep dive, we've really covered some essential ground for C# developers, haven't we? Formatting strings effectively and handling basic numerical operations correctly.
Indeed. These might seem like basics, but they are absolutely foundational. You use these skills constantly to present information clearly and accurately in pretty much any application you build.
Yeah, whether it's displaying stuff to a user on screen, writing data to a log file, generating reports, sending data over a network, how things look and whether the numbers are right is always important.
It's paramount. And having control over that presentation is key.
And thinking back to your goal as a listener of learning efficiently, you can hopefully see now how mastering these techniques gives you that direct control. It lets you communicate information with precision and hopefully make your applications more user-friendly.
Which leads us to a final thought for you to maybe mull over. Now that you have a handle on these fundamental formatting and calculation skills, how might this unlock possibilities for more sophisticated work later on?
Yeah, like how could you use these building blocks to tackle more complex data manipulation? Or maybe design more intuitive user interfaces? How can you leverage precise formatting and calculation to present complex information in a way that's really easy for someone else to understand?
It's worth considering how these basics form the foundation for much more advanced capabilities.
Definitely. And for those of you who want to solidify this, we really encourage you, go experiment. Play with the code examples we talked about. Try different escape sequences. Test out interpolation with various expressions. See what happens with integer versus decimal division.
And maybe explore some of the other string formatting options or math functions C# offers. The more you practice these fundamentals, the more comfortable and powerful you'll become as a C# developer.